This is question 37 of Civil Engineering paper GATE 2013. The soil profile above the rock surface for a 25-degree infinite slope is shown in the figure, where SU is the undrained shear strength and gamma T is total unit weight. The slip will occur at a depth of. So in this question, the soil profile of an infinite slope is given, and a different engineering property of the soil is also depicted in this figure. We need to find at which depth the slip will occur. So this question is from the topic of stability of slope. You may study in detail about the different stability condition for different types of slope by watching lecture 55, Stability of Slopes, Soil Mechanics Geotechnical Engineering 1 by Professor Dilip Kumar Baid, IIT Kharagpur. So first of all, understand at which condition this slip occurs. So for slip condition, the shear stress is greater than or equal to the shear strength of the soil. So if the shear stress exceeded the shear strength, then we can say at that depth the slip will occur. Now in this question, shear strength is given for both the layers. Now the shear stress at any depth z can be found by the equation gamma z sin beta into cos beta, where gamma is the unit weight of the soil, z is the depth at which slip is occurring, and beta is the slope angle. Now, so here in this question there are two layers, top layer and bottom layer. So we will find this slip at the bottom of the top layer and at the bottom of this bottom layer. So for top layer, this shear stress at this point at the bottom of the this top layer or first layer we can say. So for shear stress is equal to gamma into z. So gamma is 16 and depth is 5. So 16 into 5 into cos beta, which is 25 degree, cos beta, cos 25, and sin beta, sin 25. So here we will get, after calculation, we will get the shear stress as 30.64 kilonewton per meter square. So here we can see the shear strength is 40. So here we can say the shear stress is smaller than the shear strength of the soil. So in the first layer or the top layer, slip will not occur. Now find the shear stress at the bottom of this second layer or the bottom layer. So for bottom layer, we can find for bottom layer the shear stress at this depth, that is at the bottom of the layer, is gamma into z. So here the gamma will be all the overburden pressure, which is 16 into 5 plus 20 into 5. So 16 into 5 for top layer and for bottom 20 into 5, that is overburden pressure, into sin 25 and cos 25, sin 25 into cos 25. So when we calculate it, we will get the shear stress as 68.94 kilonewton per meter square, and here we see the shear strength is 60 kilonewton per meter square. So here the shear stress is smaller than the shear strength. The shear stress is greater than the shear strength. So we can say slip occur in this layer. Slip occurs in this layer. Now we are sure that the slip will occur in this layer only. So we can now we need to find the depth. So suppose the depth is z from this bottom of the top layer. Ultimately we need to find this depth from the top. So this will be z plus 5. So first we will find the this depth z. So at depth z, Z in the bottom layer, in the bottom layer, in the bottom layer. For slip condition, for slip condition, the shear stress is greater than equal to shear stress. So greater than equal to shear stress. So suppose this is at a for slip condition, the shear stress become equal to the shear strength, and we know the shear stress at any depth Z can be found by the overburden pressure at that point or that line. So overburden pressure is 16 into 5 plus 20 into Z. So 16 into 5 plus 20 into Z into sine beta. This is Z. This is Z. Sine beta into cos beta, and beta is 25 degree slope angle, 25 degree, equal to the shear strength, which is 60. So when we solve this equation, we will get Z as 3.83 meter. 3.83 meter. So we can say that depth from this top section is Z plus 5. So the depth or the required depth which we are finding is 3.83 plus 5. So which is 8.83 meter. So we can say at the depth 8.83 meter the slip will occur. So slip will occur at a depth of 8.83 meter, which is given in option A. So option A is the correct answer for this question. Thank you.